Welcome to Easy Driver, the most reliable source of automotive information on YouTube. How engine timing works, a straightforward guide. Engine timing plays a crucial role in the operation of internal combustion engines. Without precise timing, the engine would not function efficiently, impacting performance and fuel economy. Understanding how engine timing works is fundamental for any automotive enthusiast or aspiring mechanic. In simple terms, engine timing refers to the synchronization of various components in the engine to ensure that the intake, compression, combustion, and exhaust processes occur at the right moment. This precise coordination is essential for optimal engine performance. Key components involved in engine timing include the camshaft, crankshaft, timing belt or chain, and timing marks. The camshaft controls the opening and closing of the engine's valves, while the crankshaft dictates the piston's movement within the cylinders. The timing belt or chain connects these components, ensuring they move in harmony. Proper engine timing guarantees that the valves open and close at the correct time about the piston's position. This synchronization allows for efficient combustion of the air-fuel mixture, resulting in smooth engine operation and power generation. In the upcoming sections, we will delve deeper into the intricacies of engine timing, exploring the functions of each component and the precise timing sequences that make internal combustion engines the powerhouses they are known to be. Basic concepts of engine timing. Understanding the basic concepts of engine timing is crucial for grasping how an engine functions efficiently. Let's look into the essential elements that make up engine timing. Crankshaft and camshaft relationship. The crankshaft and camshaft play pivotal roles in ensuring the smooth operation of an engine. The crankshaft is like the heartbeat of the engine, converting the linear motion of the pistons into rotational motion. On the other hand, the camshaft controls the opening and closing of the engine's valves, allowing air and fuel into the combustion chamber and expelling exhaust gases. These two components are interconnected through the timing belt or timing chain, synchronizing their movements with precision. The camshaft's lobes press against the valves, ensuring they open and close at the right moment in sync with the piston's movement. This synchronized dance between the crankshaft and camshaft is vital for the engine to run smoothly and generate power effectively. Valve timing. Valve timing is a critical aspect of engine performance, influencing factors such as power output, fuel efficiency, and emissions control. The timing of the intake and exhaust valves determines when these valves open and close about the position of the pistons. Optimal valve timing ensures that the intake valve opens to allow the air and fuel mixture into the combustion chamber at the right moment and closes once the combustion process begins. Simultaneously, the exhaust valve opens to release the burnt gases after combustion, expelling them efficiently to make room for the next cycle. Proper valve timing is essential for maximizing engine efficiency and performance. It allows for better combustion, reduces emissions, and ensures optimal power delivery throughout the engine's operating range. By fine-tuning the valve timing, engineers can enhance an engine's overall performance and responsiveness. By understanding the intricate relationship between the crankshaft and camshaft, as well as the significance of valve timing, you gain insight into the inner workings of an engine and how these components harmonize to deliver reliable and efficient power output. Components of engine timing system. Understanding the components of an engine's timing system is crucial for the proper functioning of a vehicle's performance. The synchronization of various moving parts within the engine is maintained by components such as timing belts, chains, and timing gears. Let's delve into the roles and significance of each of these components in the engine timing system. Timing belt, chain. Timing belts or chains play a vital role in ensuring the accurate timing and coordination between the camshaft and crankshaft of an engine. The camshaft controls the opening and closing of the engine's valves, while the crankshaft is responsible for converting the reciprocating motion into rotational force. The timing belt or chain synchronizes these two essential components, allowing for precise operation. Regular maintenance of timing belts or chains is crucial to prevent malfunction or breakage, which could lead to serious engine damage. Over time, these components can wear out due to continuous use and exposure to heat and friction. Timely replacement according to the manufacturer's recommendations is essential to avoid costly repairs and keep the engine running smoothly. Timing gears. In certain engine configurations, timing gears are utilized to achieve the required synchronization between the camshaft and crankshaft. Unlike belts or chains, timing gears are known for their durability and reliability, offering a long-lasting solution for maintaining precise engine timing. Timing gears are commonly found in engines that require higher torque and power delivery. Their robust construction ensures minimal wear and tear, making them a preferred choice for heavy-duty applications. The meshing teeth of timing gears ensure a secure connection between the camshaft and crankshaft, maintaining optimal engine performance under varying driving conditions. By understanding the functions of timing belts, chains, and timing gears within the engine timing system, drivers and mechanics can appreciate the significance of these components in maintaining the efficiency and longevity of a vehicle's engine. Proper upkeep and timely replacements are essential practices to uphold the integrity of the engine timing system and avoid potential breakdowns. Thanks for joining us for part 1 of our series on engine timing. We hope you've gained valuable insights into this essential aspect of your vehicle's mechanics. Don't miss part 2, where we'll dive deeper into the intricacies of engine timing. Please comment, like, share, and subscribe for more automotive information like this. Thank you for watching.